For the set A containing the elements 1, 2 and 3, we need to determine which of the following relations R1, R2 and R3 possesses the properties of being reflexive, symmetric and transitive. So that means here we have three relations R1, R2 and R3 given to us. Each of these relations are defined on the set A. Our goal will be to check their reflexivity, symmetric and transitive property of each of the relation. So let's quickly go through the definition first. Let's say we have a relation R on the set A. Then R is going to be a reflexive relation if and only if the ordered pair A, A belongs to the relation R for all values of A belonging to the set A. Then R is going to be symmetric if the ordered pair A, B belonging to the relation R implied that B, A belongs to the relation R for all A, B belonging to the set A. And R is going to be transitive if the ordered pair A, B belongs to R and B, C belongs to R implies that A, C also belongs to the relation R for all A, B and C belonging to the set A. So this is the definition for the relation R to be reflexive, symmetric and transitive. Now we will check for each of the relations. So let's check for reflexivity for each of them. So reflexivity demands that for all values of A picked up from the set A, the ordered pair A, belongs to the relation. So here in our case, A contains the element 1, 2, 3. So that means the ordered pairs 1, 1, 2, 2 and 3, 3 must be present in the relation to make it a reflexive relation. Now, if we look at relation 1, so here we have 1, 1. So that's fine. We have 2, 2 and we have 3, 3. So that means all the three relations are present in the relation R1. So here we can say that R1 is reflexive. R1 is a reflexive relation. The reflexive relation. Now what about R2 and R3? Now R2 and R3 are not reflexive. R2 and R3 are not reflexive, because all of these three ordered pairs, 1, 1, 2, 2 and 3, 3, these are not present in R2 and R3. So that makes it not a reflexive relation. Okay, let's go to the second one where we check R is symmetric. So that means if we pick up two elements from the set A and we say that A, B, the ordered pair A, B belongs to R, it must imply that B, A also belongs to the relation R. Okay, so starting with R1. So here we don't have to worry about the ordered pair 1, 1, 2, 2 and 3, 3. So here actually what we are doing in symmetry is if we have A, B belonging to the relation R, we want to check that we want to interchange the position of the elements within the ordered pair. So that should give us B, A, and this new ordered pair must belong to the relation R. Only then we can say R is a symmetric relation. So it will have no problem if we consider the ordered pair 1, 1, the ordered pair 2, 2 and the ordered pair 3, 3. Okay, so here let's consider the ordered pair 1, 3. So if we consider 1, 3, then 3, 1 must be present. Okay, fine. So 3, 1 is present. If we consider the ordered pair 2, 1, then 1, 2 must be present in the ordered pair. So here we'll say that since 2, 1 belongs to the relation R1, but 1, 2 does not belong to the relation R1. So we can say, so R1 is not symmetric. This is not going to be a symmetric relation. Okay, so let's check for R2 and R3. So we don't have to worry about 2, 2. Now if we have 3, 1, then 1, 3 is present in R2. Fine. So here R2 is clearly a symmetrical relation. So we'll say R2 is symmetric on the set A. What about R3? R3 is not going to be symmetric because 1, 3 is present, whereas 3, 1 is not present. We can say since 3, 1 does not belong to the relation R3, this implies that our relation R3 is not symmetric. This is not a symmetric relation. Fine. And then finally, we're going to check if our relation R is transitive. Now, to check for transitivity, we have to be very careful how we choose the ordered pairs. The first ordered pair that we choose, which is A, B in our case, let's take a note of the second element in that ordered pair, that is B. And the second ordered pair that we choose, B comma C, if we keep a note of the first element of that ordered pair, that is also B. So that means this element and this particular element, they must match. Only then we can say A comma C, this ordered pair belongs to the relation R, and it is going to be a transitive relation. So let's go to R1. So if we consider 1 comma 1 and 1 comma 3, we can see here this 1 and this 1 matches. So by the property of transitivity, the ordered pair 1 comma 3 must be present, and we can say it's already present 1 comma 3. So here no problem. Let's take the second ordered pair and the third ordered pair, because 3 and 3 matches here, which means by transitivity we should get 1 comma 1. So 1 comma 1, that ordered pair is present, so this is fine. Next we will take 2 comma 2 and 2 comma 1. So here if we say that both of them belongs to R1, then the ordered pair, new ordered pair with elements 2 comma 1 must belong to the relation R1, and we see that it is present. Okay, we don't have to worry about 3 comma 3, because 3 comma 3, and if we say we take 1 comma 3 and 3 comma 3, we are definitely going to get 1 comma 3. Fine. Okay, so here we can see that R1 is satisfying the property of transitivity. So here we will say that it is transitive in nature. So R1 is transitive. Fine. What about R2? So R2, if we consider 3 1 and 1 3 the ordered pair, then the new ordered pair should be 3 comma 3. So here 3 comma 3, this new ordered pair does not belong to R2, which implies that it is not transitive. It cannot be transitive. Fine. Now let's finally go to the third one. So here we have 1 comma 3 and 3 comma 1. So clearly if we combine them, we should get 1 comma 3, and we see that 1 comma 3 is present. So this is a transitive relation. This is a transitive relation. So to summarize, we have shown that the relation R1 defined on the set A, it is going to be a reflexive relation. It is not going to be a symmetric relation, and it is going to be a transitive relation. Coming to the relation R2, so R2 is not going to be reflexive. R2 is going to be symmetric, and what about transitivity? And yes, it's not going to be transitive. And then finally coming to R3, R3 is not going to be a reflexive relation, R3 is not symmetric relation, but it is going to be a transitive relation.